Hello bachcho, welcome to the third part of most important questions from trigonometry for Cbse class 10 mathematics board exam. So we are at the third part. I hope you all have revised whatever we have discussed in part 1 and part 2. Those are very important, and these questions are also going to be very important for you. As you all know, my name is Jeff Wellesley. I did my BTech in mechanical engineering from NIT Rourkela. Okay, I did my BTech in mechanical engineering from NIT Rourkela. I'm a master teacher for mathematics with 6+ years of experience. In the past 6+ years, I've taught more than 25,000 students. Many of them are top ranked NITians, IITians, KVPY scholars, ISER graduate, IASC graduates, etc. Alright, and before we start, as you all know, we have a very well established and modern app, that is ODA Class app. Make sure that if you have not yet downloaded the app, now itself you can download. And if anyone is interested in more classes with us, we have a 6-day program, that is a booster course going on. You can check the description for enrolling for our booster course. Okay, with that, let's move on to today's topic. So first question for today. So today we will be discussing the proof kind of questions. As you all know, proof type of questions are very important for your Cbse class 10 board exam. So this is the first question in front of you. The question is to prove that cosec theta minus cot theta the whole square is equal to 1 minus cos theta divided by 1 plus cos theta. So let's prove LHS is equal to RHS here. Okay, so when you take LHS, what is there in LHS here? So LHS is equal to, you know, in LHS it is written that cosec theta minus cot theta the whole square. This is what is written in LHS, right? Cosec theta minus cot theta whole square. Let's prove that it is equal to 1 minus cos theta by 1 plus cos theta. So let's do one thing. Let's square that. Applying a minus b whole square. You know, a minus b whole square is a square, which is cosec square theta, plus b square, which is cot square theta, minus 2 cosec theta cot theta, right? So this will be minus 2 times of cosec theta cot theta. Correct? You will get like this. Just I apply a minus b whole square formula. You know that cosec square theta is 1 by sine square theta, plus cot square theta is cos square theta by sine square theta, because cot theta is cos divided by sine. This is actually, let's erase this part. Yes. So it is cos square theta divided by sine square theta, right? That is cot square theta minus 2 times of, you can write cosec theta is 1 divided by sine theta. So 2 times of 1 by sine theta into cot theta is again cos theta by sine theta. You can fairly write it like this, cos theta by sine theta. Correct. And sine theta into sine theta is sine square theta again. So this is equal to, denominator is completely full of sine square theta, right? Because everywhere there is sine square theta alone, and numerator will be 1 plus cos square theta minus 2 cos theta. Correct or not? 1 plus cos square theta minus 2 cos theta. This is what you have. Let's move to the next page and solve this further. Okay, so 1 plus cos square theta minus 2 cos theta whole divided by, what is there? Sine square theta. This is what you have. Correct? Now, can I write 1 plus cos square theta as 1 minus cos theta the whole square? You can write, because 1 minus cos theta the whole square is 1 square is here 1, plus cos theta whole square is cos square theta minus 2 times of 1 into cos theta. So 1 plus cos square theta minus 2 cos theta is nothing but 1 minus cos theta whole square divided by, you know that sine square theta plus cos square theta is 1, right? If sine square theta plus cos square theta is 1, you can fairly write sine square theta as 1 minus cos square theta. You can write it like this. This is 1 minus cos square theta. So this is equal to 1 minus cos square theta divided by, no, 1 minus cos theta whole square, sorry. Numerator is 1 minus cos theta whole square, whole divided by 1 minus cos square theta is 1 minus cos theta into 1 plus cos theta. Applying the identity a plus b into a minus b is a square minus b square, because 1 is actually 1 square itself. So this is basically 1 square minus cos square theta, which is 1 minus cos theta into 1 plus cos theta. So that is, this is 1 minus cos theta whole square. So 1 of the 1 minus cos theta and 1 minus cos theta cancels off. So what is left? 1 minus cos theta divided by 1 plus cos theta. Is it what was supposed to be proved? Yes, this is what was supposed to be proved. You have to prove that LHS is equal to RHS. Yes, we have already proved. This is 1 minus cos theta divided by 1 plus cos theta, hence proved. Remember, proof questions are slightly difficult for many students. Just keep practicing. Do the same question 2-3 times. Then it will start becoming very easy for you. Don't worry much about it. We are there for you to help out. Okay, whenever you need help, don't forget you can always reach out to our ODA teachers. Alright, so the first question is proved. Now the second question, you have to prove LHS is equal to RHS again. The question is, you have to prove cos A divided by 1 plus sin A plus 1 plus sin A divided by cos A is equal to 2 times of Ck. This is what we have to prove. Okay, this is what we have to prove. So what is there in LHS now? You have seen in the LHS we have cos A divided by 1 plus sin A plus 1 plus sin A divided by cos A. Correct? Let's take LCM here. Cos A divided by 1 plus sin A plus 1 plus sin A divided by cos A. Let's take LCM. What will be the LCM here? The LCM here will be 1 plus sin A into cos A, right? And what will be here? Cos square A plus 1 plus sin A into 1 plus sin A is 1 plus sin A whole square. Correct? This is what we will be having. This is 1 plus sin A whole square. So this is equal to cos square A plus 1 plus sin A whole square is 1 plus sin square A plus 2 sin A. You can fairly write it like this, applying A plus B whole square, 1 plus sin square A plus 2 sin A whole divided by 1 plus sin A into cos A. This is what we are currently having. Yes, my dear friends, this is what we have. So let's see what can be done further here. Let's do one thing. This cos square A plus sin square A, will it not be 1? So this cos square A here and this sin square A can together be written as 1. So this 1 plus already another 1 is present here. So 1 plus 1 is 2. So can I write it as 2? How did I get 2? This cos square A plus sin square A is 1 plus this 1 already is 2. And what is left? Plus 2 sin A is left. So plus 2 sin A whole divided by what we are having again? 1 plus sin A into cos A. This is 1 plus sin A into cos A. Now let's do one thing. In the numerator, can I take a 2 common? In the numerator, when I take a 2 common, what will this change to? This will change to 2 times of 1 plus sin A divided by 1 plus sin A, correct? 1 plus sin A into cos A. Yes or no? So 1 plus sin A and 1 plus sin A cancels off. What are we left with? 2 divided by cos A. What is 1 by cos A? It is Ck, right? So it is 2 Ck. So LHS is equal to RHS, hence proved. Very easy question, right? So directly what we have done, all the steps are here. Keep practicing again and again so that this gets easier for you. Alright? So the second question, kahani kadam. So can we move to the third question now? Alright. So the third question is, prove the following identities where the angles involved are acute angles for which the expressions are defined. Okay, so they are given. So you have to prove again LHS is equal to RHS. So let's see what is there in our LHS here. So in the LHS we have, so LHS is equal to tan theta. Can I write tan theta as sin theta by cos theta? I can write it as sin theta by cos theta plus or divided by 1 minus cot theta is cos theta by sin theta, right? Cot theta is cos theta by sin theta Plus again, on the numerator also you can write cot theta as cos theta by sin theta. Whole divided by 1 minus tan theta can again be written as sin theta by cos theta. You can write it like this. Now let's take the LCM. So this is equal to sin theta by cos theta whole divided by, here you are taking LCM, 1 minus cos theta by sin theta is sin theta minus cos theta whole divided by sin theta. You will get it like this. Plus again cos theta by sin theta. Here what we are having? Here you are having cos theta by sin theta whole divided by, again 1 minus sin theta by cos theta. You are taking LCM, it will become cos theta minus sin theta whole divided by cos theta. Correct? You will get this much. Now let's take the LCM, sin theta by cos theta whole divided by sin theta minus cos theta by sin theta. So this will become sin square theta whole divided by cos theta into sin theta minus cos theta. This is what it will be. And here again cos theta by sin theta whole divided by cos theta minus sin theta divided by cos theta. When you divide it, what happens? Cos theta will go to the numerator, so it will be plus cos square theta divided by sin theta into cos theta minus sin theta. You can fairly write it like this. Yes, so what we have is sin square theta divided by cos theta into sin theta minus cos theta plus cos square theta divided by sin theta into cos theta minus sin theta. Now let's do one thing. Let's simplify it further on the next page. Okay, so let's write it down once again here. So what we have currently, what we have is sin square theta divided by cos theta into sin theta minus cos theta. This is what you have, and again plus cos square theta divided by sin theta into, so it is plus cos square theta divided by sin theta into cos theta minus sin theta. This is what we are currently having. Yes or no? Yes, this is what we have currently. Yeah. Now in this term, can I write cos theta minus sin theta as minus of sin theta minus cos theta? What is the logic? Here also there is a sin theta minus cos theta. So here also, had it been sin theta minus cos theta, our life might get better. Correct? That is the logic which you have to use. You have to think carefully. You have to observe each and every term. Okay? In the first go, if you are not getting it perfectly fine, keep working out. You will start getting these insights. Okay? So from this cos theta minus sin theta, I am taking a negative outside. If you take a negative outside, what? This will remain the same, sin square theta divided by cos theta into sin theta minus cos theta will remain the same. And when the negative is taken outside, this plus cos square theta will become minus cos square theta whole divided by sin theta into sin theta minus cos theta. Because a negative, when it is taken out of cos theta minus sin theta, it will become negative of sin theta minus cos theta. Right? So now let's take the LCM in the denominator. When we take the LCM, so when you take the LCM, what will be the LCM here? Cos theta will be there, sin theta minus cos theta will be there, and again a sin theta will be there. This is what is there in the LCM. When you take the LCM, this is what will there be. And when you take the LCM, what is the only known thing which is not present? Sin. So sin into sin square will be sin cube theta minus cos theta into cos theta will be cos cube theta. This is what it will change to, sin cube theta minus cos cube theta divided by cos theta into sin theta minus cos theta into sin theta. This is what you have. How many of you know the expansion of a cube minus b cube? You all know that a cube minus b cube is a minus b into a square plus b square plus ab. Correct? So sin cube theta minus cos cube theta is, instead of a there is sin theta, so it is sin theta minus cos theta. So a minus b is sin theta minus cos theta into a square is sin square theta plus b square is cos square theta plus ab is sin theta into cos theta. Correct? ab is sin theta into cos theta whole divided by Sin theta and cos theta remains there into sin theta minus cos theta. This is what it is going to change to. I repeat what I applied here. I applied the formula a cube minus b cube is a minus b into a square plus b square plus ab. That is what I applied there. So this sin theta minus cos theta and sin theta minus cos theta gone. So what is left? You are left with sin square theta plus cos square theta, which is 1, plus sin theta cos theta is there, whole divided by sin theta cos theta. You will get like this. Let's split it into 2. This can be written as 1 by sin theta cos theta plus sin theta cos theta divided by sin theta cos theta is 1. So it is 1 divided by sin theta cos theta plus 1. What is 1 by sin theta? You know that 1 by sin theta is cosec theta and 1 by cos theta is sec theta. So it is 1 by cosec theta sec theta plus 1. Is it equal to what we had to prove? Yes, we had to prove that it is 1 plus sec theta cosec theta. That is same as cosec theta sec theta plus 1, right? Both are the same. So hence LHS is equal to RHS. Slightly difficult. 2-3 things you have applied. You have applied sin square theta plus cos square theta. Then again a cube minus b cube. Work out the same question 2-3 times. Okay. These are most important questions from NCERT. Alright. So question number 3 done. I hope everyone is understanding. Do comment on the comment box. Okay, once you watch this, if you're not understanding any part, if you need any improvement in how we teach, make sure that you comment so that we can come up with those topics which is important and how we have to change the delivery, everything. Always constructive feedback are welcome from our viewers. Okay, now the next one, prove the following identities. 1 plus ck divided by ck is equal to sin square a divided by 1 minus cos a. This is what we have to prove. Now let's see how we prove this. Let's take LHS. So you know that LHS is equal to 1 plus ck divided by ck. Correct? LHS is 1 plus ck divided by ck. So this is equal to 1 plus ck is 1 divided by cos a, right? So this is 1 plus 1 divided by cos a whole divided by 1 by cos a. Ck is 1 by cos a. Now let's take the LCM and add it up further. So what is 1 plus 1 by cos a? Isn't it cos a plus 1 whole divided by cos a divided by 1 by cos a. That's the meaning, right? It is divided by 1 by cos a. So that is equal to, this is equal to, yeah, this is what will you get from this? This is 1 plus cos a. That's all. Because cos a and cos a cancels. When you divide it by 1 by cos a and cos a cancels off, right? Now you will wonder how can we go ahead with this, because what we had to prove, have on the right side sin square a divided by 1 minus cos a. But there is no, sign of a 1 minus cos a coming in the denominator. So have we done some mistake? No, my dear friends, just listen. What we do here is, again, let us multiply numerator and denominator by 1 minus cos a. No one will stop you if you multiply numerator and denominator by the same quantity. So this 1 plus cos a, I can write it as 1 plus cos a into 1 minus cos a divided by 1 minus cos a. Fairly you can write it like this. What I did to this 1 plus cos a, I multiplied the numerator and denominator by 1 minus cos a. That is what I did. So on the numerator, what do you have? 1 plus cos a into 1 minus cos a. Can't I apply a plus b into a minus b for? A plus b into a minus b is a square minus b square, right? So 1 plus cos a into 1 minus cos a, I can write it as 1 minus cos square a whole divided by 1 minus cos a. Correct? Whole divided by 1 minus cos a. And now just one more step. What is it? You know that sin square a plus cos square a is 1. So 1 minus cos square a is sin square a. So this is equal to sin square a whole divided by 1 minus cos a, which is equal to RHS. Hence, whatever was supposed to be proved is already proved. Correct? So LHS is equal to RHS. So it is sin square a divided by 1 minus cos a will be the answer here. Fair enough? Okay. Now let's move to the next question. You have to prove that cos a minus sin a plus 1, cos a minus sin a plus 1 divided by cos a plus sin a minus 1. This is equal to cosec A plus cot A. This is a very interesting question. If you have not done it before, sometimes you might not reach the answer. Okay, now let's try to prove this. So, what is there in the LHS? In the LHS we have cos A minus sin A plus 1 whole divided by cos A plus sin A minus 1. And let's observe the right hand side. In the right hand side, there is a combination of cosec and cot. But in left side, not even a, iota of presence of, cosec and cot is there. So, think logically, how can you convert whatever is there present here? Whatever is present here can be converted to cosec and cot. How can we do it? Let's do something interesting here. You know that cosec will have sign in the denominator. Correct? So let's divide numerator and denominator by sign. Okay, so I am dividing by sin A. Numerator and denominator I am dividing it by sin A. So what happens? This will change to cos A minus sin A plus 1 whole divided by sin A. Correct? This whole thing is divided by cos A plus sin A minus 1 whole divided by sin A. So basically what I did, I divided the numerator and denominator by sin A over here. That's what I did. Now what can you do? You know that cos A by sin A, it is ck. Correct? No, sorry. Cos A by sin A is cot A. Sorry. Cos A by sin A is cot A. You know that cos A by sin A, it is cot A minus sin A by sin A is 1 plus 1 by sin A is cosec A. You can write it like this. 1 by sin A can be written as cosec A whole divided by again cos A by sin A is cot A plus sin A by sin A is 1 minus cosec A will be here. Correct? 1 by sin A is cosec A again. So that part is also done. Correct? Now let's move to the next page and try to solve this further. So what is present here is so you have cot A plus cosec A minus 1. This is what you have here, right? Cot A plus cosec A minus 1 divided by cot A minus cosec A plus 1. Because I am just changing the order. This cot A minus cosec A plus 1, you can write it in the denominator. Now let's do one thing, because in the question there is a hint given. You will have to use the formula cosec square A minus cot square A is 1. Correct? Because you have seen this in the question, right? Cosec square A is 1 plus cot square A means cosec square A minus cot square A is 1. You know this. Now let's apply that here. Okay. So this cot A plus cosec A minus of this 1, can I write it as cosec square A minus cot square A? You can write the 1 as cosec square A minus cot square A. You can easily write it like that. Whole divided by cot A minus cosec A plus 1. You can write it like this. Now what is cosec square A minus cot square A? Can I apply to cosec square A minus cot square A? Can I write it as cosec A plus cot A into cosec A minus cot A? Which formula? A square minus B square is A plus B into A minus B. So this can be written as cot A plus cosec A minus of cosec square A minus cot square A can be written as cosec A plus cot A into cosec A minus cot A. Because A square minus B square is A plus B into A minus B. That is what I did. Okay, cosec square A minus cot square A is cosec A plus cot A into cosec A minus cot A whole divided by cot A minus cosec A plus 1. Now, in this term, And this term, can I write a cosec A plus cot A common? You can easily take cosec A plus cot A common. So when you take a cosec A plus cot A common, what will be left? Here a 1 will be left, and here what will be left? Minus of cosec A minus cot A. Minus of means when you take it inside, it will become plus cot A minus cosec A. This is what you will get when you take that common, whole divided by cot A minus cosec A plus 1. This is what you will have. This cot A minus cosec A plus 1 is present in numerator also. So both cancels off. 1 plus cot A minus cosec A, 1 plus cot A minus cosec A cancels. What are we left with? We are only left with cosec A plus cot A. Isn't it same as RHS? This is same as RHS. Yes or no? This is what was supposed to be proved. This is proved as cosec A plus cot A. Hence, LHS is equal to RHS. I hope it is clear to each and everyone present here. Try to solve this question multiple number of times. Okay? So, cosec A plus cot A is RHS. Now again, let's move to the sixth question. The question is root of 1 plus sin A divided by 1 minus sin A. You have to prove it as equal to Ck plus tan A. Okay, so the question in the LHS, what is there? In the LHS we have root of, you have like this, root of 1 plus sin A divided by 1 minus sin A. Let's do one thing here. This is equal to root of, let's multiply numerator and denominator by 1 plus sin A. So it will become 1 plus sin A into 1 plus sin A whole divided by 1 minus sin A into 1 plus sin A. Remember, when in the denominator there is a combination of 1 plus sin A, 1 plus cos A, 1 minus sin A, most probably you will have to multiply it with the conjugate of denominator. 1 minus sin A should be multiplied with 1 plus sin A. So what happens? In the numerator there will be root of 1 plus sin A the whole square whole divided by, what is 1 plus sin A into 1 minus sin A? It is 1 minus sin square A. You can fairly write it like this. Yes or no? So it is root of 1 plus sin square A divided by 1 minus sin square A. What is root of 1 plus sin A the whole square? It is 1 plus sin A. Correct? It is 1 plus sin A. Correct or not? Whole divided by, what is 1 minus sin square A? You know that 1 minus sin square A is cos square A. So what is root of cos square A? It is cos A. I hope what happened here, root of 1 plus sin A whole square is 1 plus sin A. And root of 1 minus sin square A is cos square A. Root of cos square A is cos A. So it will become 1 plus sin A whole divided by cos A, which is equal to 1 by cos A, which is Ck, plus sin A by cos A, which is tan A, which is equal to RHS. Hence proved. Is it clear to all of you? Hence this is proved. So it is Ck plus tan A has to be the right answer. So LHS is equal to RHS. Now again the next question, very simple question. You have to prove that sin theta minus 2 sin cube theta whole divided by 2 cos cube theta minus cos theta is tan theta. Let's focus on the LHS here again. Let's focus on the LHS. In the LHS there is, you can take sin theta common in the numerator, right? So when you take the sin theta common, it will be sin theta into 1 minus 2 sin square theta whole divided by, here you can take cos theta common, so it will be cos theta into 2 cos square theta minus 1. This is what it will change to. Correct or not? So this is what we have. So this is equal to sin theta by cos theta. I can fairly write it as tan theta. So this is tan theta into, again, 1 minus 2 times of, can I write sin square theta as 1 minus cos square theta? You can write it like this, because sin square theta plus cos square theta is 1. So this sin square theta is 1 minus cos square theta. Correct? Whole divided by 2 cos square theta minus 1. This is what we have currently. So what I did, in the numerator the sin square theta was just written as 1 minus cos square theta. Open the bracket further. So this should be tan theta into 1 minus of 2 plus 2 cos square theta. This is what happens in the numerator, whole divided by 2 cos square theta minus 1. So this is equal to tan theta into 2 cos square theta minus 1 whole divided by 2 cos square theta minus 1. 2 cos square theta minus 1 and 2 cos square theta minus 1 gone. So what are we left with? We are left with just tan theta alone. So the answer is LHS is equal to RHS. Hence it is proved that sin theta minus 2 sin cube theta divided by 2 cos cube theta minus cos theta. We have proved it as tan theta. The right answer is tan theta, hence. Again, now question number 8, very important question. Multiple number of times this had come in Cbse board exam. The question is to prove that sin A plus cosec A the whole square plus cos A plus sec A the whole square, it is equal to 7 times of tan square A plus cot square A. This is what we have to prove. Now let's take LHS. So LHS will be equal to, what is sin A plus cosec A whole square? Can I write sin A plus cosec A whole square applying A plus B whole square as sin square A plus cosec square A plus 2 times of sin A into cosec A? You can write it like this, applying A plus B whole square. Again, cos A plus sec A whole square, can I write it as cos square A plus sec square A plus 2 times of cos A into sec A? You can fairly write it like this. Correct. Now let's do a permutation and combination here. You can combine this sin square and cos square. Sin square A plus cos square A, can I write it as 1? You can write it as 1. Again, can I write this 2 sin A into cosec A? What is sin A into cosec A? You know that cosec A is 1 by sin A. So sin A into cosec A will become 1. Again, cos A into sec A will become also 1, right? Because sec A is 1 by cos A. So both of them cancelled. So what are we left with? We are left with sin square A, and this 2 is there. Again, this 2 will be there. So plus 2 again, plus cosec square A plus sec square A. That is equal to 5 plus cosec square A plus sec square A. Have we reached the answer yet? No. What we have on the right side is tan square A. You need tan square A and cot square A. How can you convert cosec square A and sec square A in terms of tan square A and cot square A? You know that cosec square A minus cot square A is 1, right? You know that cosec square A minus cot square A is 1. So cosec square A can be written as 1 plus cot square A. I hope you have to by heart the identities. You know that cosec square A minus cot square A is 1. So cosec square A is 1 plus cot square A plus sec square A again. You know that sec square A minus tan square A is 1. So tan square A, sec square A can be written as 1 plus tan square A. Fair enough? So this is equal to 5 plus 1 plus 1, which is 7, plus cot square A plus tan square A. This is equal to RHS, right? Hence this is equal to RHS. So LHS is equal to RHS. Hence it is proved that sin A plus cosec A the whole square plus cos A plus sec A the whole square is 7 plus tan square A plus cot square A. Very simple question then. Correct? Yes. Now let's do one more question. Cosec A minus sin A into sec A minus cos A. You have to prove that as equal to 1 divided by tan A plus cot A. Let's take LHS. This is a slightly different kind of question. Let's do it. So in LHS, cosec A minus, let's take LHS first, okay? Cosec A, can I write it as 1 by sin A? Minus sin A will remain the same. Into sec A, can I write it as 1 by cos A? Minus cos A, let us keep it the same. You can write it like this. LHS, let it be written like this. Now when you take the LCM, what happens? What happens is, this will become 1 minus sin square A whole divided by sin A into 1 divided by cos A minus cos A, which is 1 minus cos square A whole divided by cos A. You can write it like this. Yes or no? What is 1 minus sine square A? All of you know that 1 minus sine square A, it is nothing but cos square A, because sine square A plus cos square A is 1. So it is cos square A by sine A into 1 minus cos square A is again sine square A. So it is sine square A divided by cos A. So what does it become? Cos and cos cancels, right? And sine cancels. So what are we left with? We are left with a cos A and a sine A. This is what we have in the LHS now. Is it same as RHS? Because this is the maximum we have reached. We have reached that cos A cut, cos A sine A. We have not yet reached the answer. So let's do one thing. Now let's try to simplify the RHS and make RHS as cos A sine A. Let's think about that. Okay. So what is there in the RHS? RHS is 1 divided by tan A plus cot A. Correct or not? This is RHS 1 divided by tan A plus cot A. That is 1 divided by tan A is sin A by cos A. And cot A is cos A by sin A. We can write it like this. So that is same as writing 1 divided by, taking the LCM, it will be sin square A plus cos square A divided by sin A cos A. We can fairly write it like this. Sin square A plus cos square A whole divided by sin A cos A. This is what we have here. So that is equal to 1 divided by, you know that sin square A plus cos square A is 1. So it is 1 divided by sin A cos A. So that is equal to sin A cos A. Correct? Because you will multiply it with the reciprocal. So this is what we have proved in RHS. So RHS is also sin A cos A and LHS is also sin A cos A. Hence you can show that LHS is equal to RHS. I told you this slightly different question. If you have not proved before, it's unlikely that you will reach here because you will get confused what we are doing here, right? So 1 divided by 1 by sin A cos A is sin A cos A will be the answer here. Alright. Now the final question for the day. What is there in this question? You have to prove that 1 plus tan square A whole divided by 1 plus cot square A, you have to prove that as equal to 1 minus tan A divided by 1 minus cot A the whole square. That is indeed equal to tan square A. So all these two things are equal to tan square A, you have to prove. Let's take the first one. 1 plus tan square A whole divided by 1 plus cot square A. This is what you have. This is equal to 1 plus tan square A whole divided by 1 plus cot square A can be written as 1 by tan square A. You can write cot square A as 1 by tan square A. So this is equal to 1 plus tan square A whole divided by 1 plus 1 by tan square A is tan square A plus 1 whole divided by tan square A. Correct? So 1 by tan square A divided by 1 plus tan square A divided by, again this is 1 plus tan square A whole divided by tan square A. 1 plus tan square A, 1 plus tan square A gone. What are we left with? Only tan square A. So we have proved the first one is equal to tan square A. We have proved that one. Now let's go ahead with the second one also. Second one is, again LHS is equal to, what is there? 1 minus tan A divided by 1 minus cot A whole square. So it is 1 minus tan A divided by 1 minus cot A whole square. So this is equal to 1 minus tan A divided by 1 minus cot A is 1 by tan A the whole square. You can write it like this. So that is equal to 1 minus tan A whole divided by tan A minus 1 divided by tan A the whole square. Isn't it? Now tan A minus 1 is negative of 1 minus tan A, right? So this can be written as 1 minus tan A whole divided by tan A minus 1 is negative of 1 minus tan A. This is negative of 1 minus tan A, right? Whole divided by tan A. This whole thing the whole square. So 1 minus tan A cancels. So this is negative of tan A the whole square, which is equal to tan square A. Isn't it same as what we had to prove? So this is also proved. Hence, this is also done. So, hope you all enjoyed this session. You have to work out these questions again and again because this is very, very important for your upcoming board exams. Okay, because NCERT is this exercise, one question is most probably coming from it. Okay, and as I have told you already, those who have not yet downloaded our app, you can download the app. There are a lot of free sessions also going on. Apart from that, this is a 40-minute session. If you need more classes with us, we have a booster course going on where you will be taught by the top class IITians and NITians with years of experience. It will be a 1-week program. 3 maths class and 3 science class will be there. You will be given the support of a personal teacher who will clear your doubt throughout, and you can also complete your homework in our app itself during the booster course, and tests will be conducted, and whatever we teach, the complete e-book also will be given to you. So don't miss this opportunity. The price will vary from 29, 49 or 99 depending on which grade you are in. To enroll, you can press on the link in the description box. There is the link. You can press on that and enroll now itself. Don't waste the time. The seats are very, very limited. And those who are downloading your app, you will also get a few coins which can be used for getting smartwatch, smart speaker, smart mobile, etc., etc. And last not but the least, don't forget to like, share and subscribe to our YouTube channel and share this important video with all your friends who are going to appear for your CBSE board exams. So I'll come up with one more video. Until then, bye bye.